In this video, I'm going to walk you through the cardiac cycle. This all builds on the previous slides and video lectures, so hopefully you're really starting to get an idea of the pattern based on the electrical conduction system and what we see in the EKG. The heart contracts in a very predictable way. The very first phase that we can see in this part of the cycle is called atrial systole. Systole means contraction. So for all intents and purposes, both right and left atria contract simultaneously, pushing blood from the atria through the open AV valves and into the ventricles below. Then the ventricles are going to contract. That's ventricular systole. There is a tiny fraction of a second during the first part of ventricular contraction where the AV valves are closed, but the pressure in the ventricles hasn't risen high enough to open the semilunar valves. Excuse me, we call this the period of isovolumetric contraction. Now don't be intimidated by that phrase, contraction, because we're in the systole phase. The ventricles are contracting. But the word isovolumetric means the same volume. Iso means the same, like isotonic or isolateral. Oh, wait, that's not right. Anyway, isovolumetric, you just have to believe me, it means the same volume. Now, after just a fraction of a second, the pressure rising and rising and rising eventually blows open the semilunar valves, and we enter this. The ventricles are still contracting, they're sort of squeezing, but now blood is flowing out. This is the ejection period, or the period of ejection. At the end, when nearly all of the blood is squeezed out, the ventricles have sort of reached that point where they can't squeeze any more out, and the semilunar valves close. And so we're technically in our first state of relaxation, ventricular diastole, but all four heart valves are closed. So to say it a different way, we would say after the AV valves have closed, After the semilunar valves have closed, but before the AV valves open, we're in a period of isovolumetric relaxation. Look, this word matches. Diastole. The ventricles are relaxing. That's diastole. So the period of isovolumetric relaxation. Then, the blood pressure in the atria begin to rise just because of what we call venous return, right? Your blood pressure never drops to zero. Even between cardiac cycles, it doesn't drop below 80 usually, as in 120/80. And so during diastole, there is still positive venous return from the pulmonary circuit and from the systemic circuit. And so we see blood begin to accumulate in the atria and flow through the opened atrioventricular valves. This is called passive ventricular filling, right? The ventricles actually fill more than halfway before the atria contract. Passive ventricular filling. So the job of the atria is really just to top off the ventricles, not necessarily to fill them in a proper sense. So this is what you want to do, ladies and gentlemen. Make a flashcard. You might even try drawing these illustrations, or at the very least, blow these images up and print them out and cut them apart. Then practice putting them into the right order so you can really begin to visualize this cycle. The reason you want to do that is we're going to get to this amazing and potentially award-winning infographic. Notice the same phases specified here. And this one is beautiful because it's color-coded by columns, so you can see how much time each of those phases takes and how those phases we just reviewed relate to both the firing of the electrical conduction system, the EKG, and the heart sounds. You can also see those phases as they relate to both the volume of the ventricles, which is in this row, and the pressure that we see in the left ventricle and the aorta. All of those things line up, and so this is really a great way of beginning to put all of these things together. And as a matter of fact, a year ago or a year and a half ago, I had a young lady at the beginning of her test, by memory, draw this out so that she could use it as a reference as she worked her way through her test, which, not surprisingly, she got a 100%. I think she actually had like 103 on it. But anyway, this is what we want to do, try to work through all of that. It's a great video. You can watch this one to help reinforce the ideas of the electrical conduction system and how they relate to the EKG. What I want to talk about is the heart sounds. Think about this. Lub-dub, lub-dub, lub-dub. We all know this familiar rhythm of the heart. It isn't, the heart sounds aren't equidistant. They're not evenly spaced out, or that would sound like a 4-on-the-floor heartbeat, right? Lub, dub, lub, dub. It's not like that. It's sort of more like a horse. Lub, dub, lub, dub, lub, dub. And maybe I'm exaggerating it just a bit. What you hear is one sound and a small gap, and then the second sound, and then a long space, and then you hear the pattern again, right? It's not equally spread out. The first heart sound is called S1, and the second heart sound is called S2. What causes these heart sounds is the closing or closure of the heart valves. Very much in the same way that a windstorm might slam closed a door in your bedroom, right? Bam! Out of nowhere, you hear this door slam shut like a ghost has done it. In the same way, pressure drives the valves closed, and when they slam shut, they make a sound. So the first heart sound, S1, has to do with the atrioventricular valves closing, and it's really most closely associated with closure of the mitral valve. Can you think why that may be? The mitral valve is subject to even higher pressure than the tricuspid valve is. Being on the left side of the heart, the mitral valve is a bit louder. I say it's a clap to a snap. The tricuspid is a snap, but the mitral, bicuspid, is a clap. And so if I could do both of those at the same time, you'd probably hear the clap. So, in the same way, although both AV valves close at the same time, we tend to associate S1 with the mitral valve. In the same way, although both aortic and pulmonary semilunar valves are closing at the same time, we tend to hear the aortic valve much more loudly than the pulmonary semilunar valve. It is a clap to a snap. So what causes S2? You should tell me the aortic valve. Occasionally we hear a third heart sound, just turbulent sound, or a valve problem, which can result in a swooshing sound, which we call a murmur. So instead of lub-dub, it might sound like this. Lub-dub, shlub-dub, 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 or shlub-dub, shlub-dub, or flop-lop, flop-lop, or, well, you could imagine all kinds of abnormal heart sounds. Look at this, the dicrotic notch. The dicrotic notch is this tiny little dip in aortic pressure that we see right here on this award-winning infographic. The significance of that is that this is really when the aortic valve closes, making S2. See that? See how we can draw vertical lines through this award-winning infographic? So during isovolumetric relaxation, and actually at the very beginning of it, the end of ventricular systole and the beginning of its relaxation phase allows aortic pressure to slam the aortic valve shut, and then pressure rises ever so slightly before heading right down. The reason I'm pointing this out is this is actually the point in time where the coronary circuit is perfused. Remember that? The coronary arteries are actually receiving blood from the aorta. And so in order for the coronary ostia, the openings to the coronary arteries, to be open, the aortic valve has to be closed. And so as soon as it slams shut in this tiny little pulse of pressure, we would actually see blood moving through the left and right coronary arteries and perfusing the myocardium. Okay, what else do we have to take a look at? This is really an important image because it's putting everything together. So I'm going to walk you through the cardiac phases and then draw these vertical lines up and talk you through what I see here. Starting with passive ventricular filling. Remember, at the start of the cardiac cycle, even before the SA node fires, the residual blood pressure from the last cardiac cycle will force blood through the open AV valves. And what we're going to see is that the ventricles fill more than halfway. That's what this line represents right here. Passive ventricular filling is this curvature right here. Notice that all four heart valves are quiet. Sorry, all four heart chambers are quiet at this point. We're in the long ventricular diastole period, and it's before the P wave. It's before the SA node fires, and we begin to excite the atria. So these blue columns right here represent this passive ventricular filling, and specifically this upward black curve shows us that the ventricles are filling, and look at that, they fill more than halfway before the atria contract. That brings us to the P wave. The very first upward deflection of this P wave curvature is the firing of the SA nodes. Remember, the pacemaker of the heart, which causes subsequent atrial depolarization. That's what the P wave measures. And electrical excitation always precedes contraction. And so that's why we see at the peak of P wave, we see the start of atrial systole. The atrial myocardium is now contracting and forcing the ventricles to be filled up. And that's what this second little hump represents. Then the atria begin to relax, and we see QRS. That represents ventricular depolarization, right? We're electrically firing the ventricles. And in much the same way as we had seen with the P wave, the contraction phase starts at the peak of QRS. And so if you draw a line straight up, you can see that's the beginning of systole. This very narrow yellow column is isovolumetric contraction. So let me explain that to you. We see the pressure in the ventricles rising, and the atrioventricular valves are slammed shut right at the beginning, giving us the sound S1, mitral valve closure. And the pressure rises until the semilunar valves open, namely the aortic valve. So this very narrow yellow column is isovolumetric contraction. The volume is not changing during contraction, and the volume is not changing because all four heart valves are closed. As soon as the aortic valve opens, blood flows out of the ventricle and into the aorta, out of the right ventricle and into the pulmonary trunk as well. But this graph is specifically looking at the left side of the heart. Look at the aortic blood pressure. It rises significantly because of that infusion of blood, ventricular ejection. Look how narrow this phase is. Not quite as narrow as isovolumetric contraction, but we're squirting the blood out of the ventricles until we see that pressure inversion. Suddenly there's a greater pressure in that distended aorta and lesser pressure in the ventricle. Why? Why did the pressure go down? Because we have reached diastole. So as soon as the left ventricle begins to relax, bam, it slams shut the aortic valve because there is suddenly higher pressure in the aorta and lower pressure in the ventricle. This begins a phase called isovolumetric relaxation. It's sort of like this little sucking right before the AV valves open. The volume is not changing. We see ventricular pressure dropping and dropping until it is below the pressure of the diastolic blood pressure, which will then open the AV valves. And that's what we see right here. Atrioventricular valves open. And now we're right back into those blue columns. Do you remember what those ones are? Passive ventricular filling. What event marks the end of passive ventricular filling? The P wave and subsequent atrial systole. Which heart valves close at the beginning of ventricular systole? It's the atrioventricular valves, tricuspid and mitral. They get slammed shut as soon as the ventricles begin to contract. Which heart sound do we associate with closure of the AV valves? S1, and primarily the mitral valve. Potential test question here, as I have been phrasing them already. Describe the period of isovolumetric contraction and tell me which valves are open and which valves are closed. And you should tell me it is the very start of ventricular systole. All 4 valves are closed and pressure in the ventricles is rising. Which event marks the end of isovolumetric contraction? The opening of the aortic valve, which moves us into ventricular ejection. What event marks the end of ventricular ejection? Diastole, right? As soon as the ventricles begin to relax, we are into isovolumetric relaxation. That's the first phase of ventricular diastole. And as soon as the atrioventricular valves open, blood begins to flow through the open AV valves and into the ventricles below, a process called passive ventricular filling. So there you go. What a beautiful and amazing award-winning infographic. You can flip back and forth between the heart sounds slide, the EKG slide, the cardiac cycle slide, and this slide to make sure you can tell me absolutely everything that you can about this graphic right here. So a good time to pause and check in with how much you've absorbed so far.